Imagine drifting through the vast emptiness of space, where stars are born, die, and sometimes mysteriously vanish without a trace. Welcome to the cosmos, where the laws of physics can sometimes feel more like a cosmic riddle. Today, on Think Cosmos, we're diving into the enigmatic world of black holes, those astonishing celestial objects that seem to warp the very fabric of reality. First, let's unravel the mystery of how black holes are born. You may know that they form from the remnants of massive stars that have exhausted their nuclear fuel. But here's where it gets fascinating. When a star runs out of fuel, it can no longer support itself against gravitational collapse. What happens next is a spectacular explosion known as a supernova. This event is not just a flashy light show. It's the birth cry of a black hole. If the core left behind is more than about 3 times the mass of our sun, gravity becomes so intense that not even light can escape its grasp, marking the creation of a black hole. But it doesn't end there. The life cycle of a black hole continues with a phenomenon called accretion, when a black hole pulls in surrounding material, like gas and dust from nearby stars. It creates an accretion disk. This disk is incredibly hot and emits powerful X-rays, making black holes some of the brightest objects in the universe, despite their name. It's a cosmic dance of destruction and creation. As the material spirals inwards, it heats up, and the energy released can outshine entire galaxies. This is why we can detect black holes, even though they are invisible. Now, let's venture into the realm of supermassive black holes, which can be found at the centers of most galaxies, including our own Milky Way. These colossal entities can have masses equivalent to millions, or even billions of suns. But how did they get so massive? One theory suggests they could have grown through a process called merger. Over billions of years, smaller black holes and stellar remnants collide and merge, creating larger and larger black holes. Alternatively, they may have formed from the direct collapse of massive gas clouds in the early universe, rapidly accumulating mass as they feed on their surroundings. Here's where it gets even more mind-bending. Recent studies suggest that supermassive black holes might also play a critical role in the evolution of galaxies themselves. They can influence star formation rates and galaxy dynamics, acting as cosmic engines driving the growth of structures in space. This interconnectedness of black holes and galaxies raises questions about the very nature of our universe. Are they merely passive consumers of matter, or do they actively shape the cosmos around them? As we ponder the complex nature of black holes, consider this. What would happen if we could somehow explore the boundary of a black hole, known as the event horizon? This point marks the ultimate boundary, beyond which nothing can escape. If we were to fall into a black hole, we encounter a phenomenon known as spaghettification, where the difference in gravity between your head and feet would stretch you into a long, thin shape, like spaghetti. It's a stark reminder of the extreme forces at play in these cosmic giants. So, as we wrap up our exploration of black holes, let's reflect on their profound implications for our understanding of the universe. They remind us that the cosmos is not just a backdrop for celestial bodies, but a dynamic, ever-evolving landscape filled with mysteries waiting to be uncovered. Before you go, I invite you to ponder this. If black holes can warp space and time, what other cosmic phenomena might be lurking in the shadows of our universe, just waiting for us to discover them? Join the conversation in the comments below, and let's continue to think about the cosmos together. Until next time, keep looking up.